Hey students, I wanted to show you how now that we've derived equations for our highway model, we can create an interactive graph using Desmos in under about 3 minutes. So I just want to remind you, this is how we decided to set up our scenario. We have a general quadratic that's our curved section of highway. We've got the two straight sections modeled as lines with slope m1 and m2. The connection, we've decided to set our origin right where the first straight section hits our connector. And we've decided to set a variable h to denote the horizontal distance to where the connecting highway hits the second segment. And we were able to drive an equation for what should the coefficients a and b be in terms of the two slopes so that we're sure that they connect smoothly here, so that the derivatives are equal and the y values are equal. So let's start doing it. I'll start by creating my general quadratic. F of x equals ax squared plus bx, and then remember the c value is 0. We'll replace these sliders in a second with the computed values that we derived in class. Let's create the equations for our lines. So I know my first line is y equals the first slope times x. If you hit an underscore, here, let's do this again. If I type m_1, it will create a subscript 1, which is a great way of organizing your variable names, especially if you have a whole lot of them. Here, let's make this look a little better. Okay. So that's my first line. Let's create the line for my second segment, which should be about here. Looking at my picture again, you remember the point where it connects to my parabola is going to be at a horizontal distance h. So if I use point slope form for this line, it should be y equals m2 times x minus h plus f of h, because f of h is the y value where this point is. So my second line, I'll say y equals my second slope times x minus h plus f of h. And I'll create sliders for those things. So let's make my m2 be negative, and I'll make my h a little bit larger. And it doesn't really look like you're expecting it to look like yet, but that's because we didn't set the coefficients in our parabola to be dependent on the slopes at all. So, I mean, they don't match up the way that we want them to match up. So again, taking the equation that we derived, I'll set my b coefficient to m1, and I'll set my a coefficient to this thing. So my b coefficient is m1. My a coefficient will be m2 minus m1 divided by 2h. And now this looks a lot more like we're expecting. And if you want to move h back and forth, you see that the total horizontal distance to where I connect has changed. And I can change my slopes as well. So this is, I'm changing my incoming slope, and here I'm changing my outgoing slope. All right, well, this is okay. It might be more convenient to domain restrict some of our functions so that you actually see the smooth connections. So let me show you how to do that. I'm going to domain restrict my connector here to only go between 0 and h. So the way you do this is with a curly brace. If you hit the shift key and then the square bracket, it will create these curly braces. And now you just enter the domain you want. So 0 less than x less than h. And now I've domain restricted my function. Let's domain restrict my lines also. So for this one, I want x less than 0. I guess we can do less than or equal to 0. For this one, I want x greater than or equal to h. Okay, why did my line disappear? Ah, I see. Look, I'm trying to use the f function here at the value h, but my f function is not defined for the value h because I've restricted its domain to be less than h. So that means this value is not defined, and that's why this entire line isn't showing up, although it would have been nice if they told me that. So I'm going to change this so that it is, here I'll change these to be equal, and I'll make these just less than and greater than. All right, so now I've got line 1 is defined when x is less than 0, line 2 is defined when x is greater than h, and my parabola is defined between 0 and h. All right, so now it looks a lot more like a highway the way I was expecting it to. And I can, again, sort of drag it around, and it looks really nice. The last thing I want to do is organize these results. This is kind of ugly. So especially if you want to put more things into this graph, which you may well. So if you go up here, you can say folder. So I'm gonna make a folder called highway equations. And I'm going to go ahead and drag just my equations into here. Close that. And now I can collapse this. And I'm going to create another folder called highway parameters. And I'll drag all of my parameters in here, starting with the ones that I might want to change. M1, M2. Okay. And now I can collapse that. Oops. Oh, wait. Okay, drag them in. Thusly. Okay, now I can collapse this. And now I can collapse that. So now this is a lot more organized. So if I don't have to look at the equations, I can just change the parameters if I want to, the h and the m's. Or if I want to tinker with the equations, I can just look at the equations. All right, I hope this has been helpful.